Now let's move beyond flat mirrors and explore the world of spherical mirrors. These curved surfaces open new possibilities for manipulating light and forming images. So in general, there's two types of spherical mirrors. Concave mirrors, the reflecting surface curves inward, like the inside of a bowl, and concave mirrors can converge focused light rays. And also convex mirrors, the reflecting surface bulges outward, like the back of a spoon. Convex mirror diverge, spread out light rays. So what do I mean? So let's imagine once again we have an optical axis, and here we have our converging mirror. So you can see that converging mirror is a spherical mirror that bends inwards. Let's imagine that we have some sort of, so it's defined by its radius, which is called radius of curvature. Let's imagine that we have a point source located at infinity. From a point source located at infinity, light rays will come straight to the mirror. And what will happen that we'll see that if we shoot like two light rays from infinity, what will happen, we'll see that any point on this from the spherical of this spherical surface will focus this light rays at the focal point, which we call F. And this focal and distance from this point to the focal point for a spherical mirror is what we call a focal distance, small f. So interesting. So that was a converging mirror. There are also diverging mirrors. So as you can see here, diverging mirror is defined by actually being convex, not concave, but convex, bending outwards. So let's imagine once again that we shoot once again two light rays from infinity that would go like this, and what would see would happen that the mirror would reflect back, diverge those light rays. And if we'd like to form an image, we would look for the point of intersection of these two rays, and we'll see that that the intersection would happen at the end, at the back of this diverging mirror. Once again, we have focal point in the center of this spherical diverging mirror. So so how spherical mirrors work? Once again, concave mirrors, parallel rays of light incident on a concave mirror converge at the focal point after reflection. And this allows them to form real images of distant objects, making them ideal for telescopes. For example, here you can see a telescope that we'll see in more detail in the future lectures. It's so-called Schmidt-Cassegrain telescope. Incoming beams come through this aperture. They actually hit this converging mirror, and the light rays, as you can see, converge here, hit another mirror, converging mirror, and are focused here to the eyepiece. So that would be application on the converging mirror, for example, for space-based applications. For diverging mirror, you can see, for example, application, it's used in such applications as surveillance mirrors. That would be example where they used. And how the convex mirrors work. So parallel rays of light incident on a convex mirror diverge after reflection, appearing to originate from local point behind the mirror. And yes, so this produces virtual or bright and smaller images, making them useful for rear view mirrors and security surveillance mirrors like this.